Hi, today we'll have another problem on rational inequalities. No? And now we're going to use inspection of signs method. The other one is case method, but this time we're going to use this inspection of signs method. And we're asked to find the solution to the inequality x plus 3 over x minus 1 is greater than or equal to 0. So for our solution, first we're going to transform. We change this inequality sign to equality sign to an equation. So by doing that, we're going to find the critical values by changing it to the equality sign. So this one, the denominator is x plus 3 is equal to 0. And the numerator is x minus 1 is equal to 0. So we get the critical values. X is equal to negative 3, and the other one is x is equal to 1. Now, that is by transposing this 3 and negative 1 to the other side of the equation, to the right side of the equation. So our critical values are the values of the numerator and the denominator, which are negative 3 and positive 1. So we're going to graph these critical values on our number line. So we have here 0 and 1, 2, 3, 4 to the right, and negative numbers to the left. So we're going to inspect 3 regions. The other one is, the first one is from negative 3, from these 2 critical values, from negative 3 to negative infinity, and from negative 3 up to positive 1, and the last one is from positive 1 to positive infinity. So we test each region, these 3 regions here. We're going to test by assigning or getting a test point. We are going to test 1 point for each region. So we're going to tabulate, and you choose a test point K. We call the test point K. So for these 3 intervals, we're going to assign this test point K. So for our numerator x plus 3, we choose a test point K from negative infinity. This is 1. Negative infinity to negative 3. So choose a number between these the 2 regions here, 2 intervals here. So we choose negative 5. So negative 5, that will be negative 2. So this is negative 2. So we get the 1 point here. That is, where's that? Negative 2. Negative 2. So for the denominator, negative 5 and negative 1 is negative 6. And then we assign these 2 to both the numerator and denominator. We get a positive. Negative divided by negative is positive. So if this is a positive number, number here, the result will be that is greater than or equal to 0. For the interval between negative 3 and 1, we choose 0. We assign 0 for the numerator, which is 0 plus 3 is equal to 3. 0 minus 1 is negative 1. We divide denominator by numerator, we get a negative number. So that is less than or equal to 0. And the last one from this region here, 1 to positive infinity. So for this region, we choose a test point K. So 5, assign that to both the numerator and the denominator. So 5 plus 3 is equal to 8. 5 minus 1 is equal to 4. 8 divided by 4 is positive 2. So this is greater than or equal to 0. But the problem asks for a number, for a region, greater than or equal to 0. So these fractions ask for solution greater than or equal to 0. So by inspecting the result of our inspection of science method, these are the results. So the first one and the last one are greater than 0. So it fits the inequality. No? So our final answer is x, no? That is from this region, from negative infinity to negative 3. And the other one, that is union, no? X is greater than or equal to 1. So that's it, no? This will be our answer for this particular problem. So thank you for watching our videos, and please subscribe to my YouTube channel by Wilfredo Tan, and don't forget to click that bell icon. Thank you, and see you again later.